So last class we have seen the expression for derivation of the expression for alternating current in a resistor applied with a alternating voltage. When an alternating voltage source is actually applied across the resistor, what is the expression or equation for the alternating current? The derivation we have seen, it's entirely based on the Kirchhoff's voltage law, and we have seen that the current or the alternating current flowing through the resistor, it actually it it's coming as a sine function of time. That is, as time changes continuously, the current passing through the resistor also will be changing. Once for a small time interval it flows in the clockwise direction, next time interval it flows in the anti-clockwise direction. That's what we have actually derived based on the Kirchhoff's voltage law. So next topic is actually something related to in the alternating current passing through the resistor, because the current is continuously changing with time. Different definitions, very important definitions related to current will be actually have to be learned in the when alternating current is actually flowing through the resistor. So all these definitions, they're actually here it's at the bottom of the screen, it can be seen. So these definitions are all roughly we have been using all these definitions almost from the first lesson of electricity to the last lesson. Last lesson was actually what? Last lesson was actually the electromagnetic induction. Almost throughout the lesson we have been using these quantities, actually uniform electric current, non-uniform electric current, roughly, only roughly, but we did not see the exact definitions. So these exact definitions are very useful in the understanding of the alternating current circuits. So this is the next topic related to the alternating current circuits. These four definitions, actually here it can be seen at the bottom of the screen. Four definitions are actually given as a side heading: uniform electric current, non-uniform electric current, average electric current, and instantaneous. All these four definitions are very useful for this particular lesson, alternating current circuit. So we have used them almost intuitively, that means without exact following any definitions, just from rough meaning, because all these four definitions are exactly similar to the definitions of something like exact similar definitions we have seen in mechanics, that is uniform velocity, non-uniform velocity, average velocity, and instantaneous velocity, or uniform speed, non-uniform speed, average speed, and instantaneous speed. Exactly the same way they have been defined. So roughly we have been using all these terms without really following the definitions, but the definitions here are very important, because the most powerful things in science and technology are definitions. Each and every topic has to be understood based on the definitions, based on the scientific definitions. That only is said to be the proper understanding in science and engineering, or science and technology. Now all these four definitions are actually related to a very simple definition. Now, this definition is the most powerful definition in one particular branch of mathematics. It is called statistics. This is the most powerful definition of all things, or all different definitions used in statistical mechanics, or different operations used in statistical mechanics. This definition is very simple. So this also we have used many times in different topics, not only in the 12th class, 11th class, even in school also you have been using this particular meaning, simply just roughly. But roughly something we are using without really following the definition means that's only with a rough understanding. So understanding in science and technology mainly depends upon the using, understanding, and also the using of the, or and also the applying of the exact definitions. That's a so here the exact definition is very useful for this next topic, which is actually related to the four definitions of different kinds of electric currents. So uniform electric current, non-uniform electric current, average electric current, and instantaneous electric current. Now firstly, considering this definition, average or arithmetic mean, it's also called as mean in statistical mechanics. That is in simple statistics, which is a branch of mathematics. Now again, similar to, so just by chance I have used this word statistical mechanics. Now statistical mechanics is a branch of mechanics actually, which is entirely based on statistics. Now statistics is really a branch of mathematics which deals with, say, many objects at a time, not just one object, two objects, three objects, say hundreds of objects or tens of objects, 20 objects, 30 objects, 100 objects. For example, the average marks in a classroom, average physics marks in a classroom, or some 100 objects, 100 stones you are throwing. What is the average speed of the stones? Different stones or different thousands of molecules in a small container, an extremely large number of gas molecules or liquid molecules are present. What is the average velocity of the molecules of the liquid or molecules of the gas? So it's something related to statics itself, is mainly related to a large number of objects. So the mechanics related to large number of objects is called statistical mechanics. In both these branches, so one is branch of mathematics, one is branch of physics, or exactly speaking, branch of mechanics. So this quantity is very, very useful, average or arithmetic mean. So how average is defined? So it's simply called as average, or simply it's called as mean, or more clearly it's called as arithmetic mean. It's something related to, as we have just now seen, it's something related to many objects at a time, considered at a time. So how it is defined? So this is a very, very simple, very, very powerful definition. But whatever, these two topics are actually not related to the marks. No way they can be given in the exam, but they are very, very important for the understanding of the remaining topics on this, in this particular lesson, that is alternating current circuits. So I'm not putting any marks. I just kept the importance, but I did not put any marks. Just see here, 2 marks or 3 marks I'm not putting because they can't be asked in the exam. But without this, understanding is not possible. So what's the definition of average? Now consider a particular quantity, say a quantity Q. So I'm just dividing the page into left half and right half. Now consider a particular quantity as a Q, a quantity Q. Say this quantity Q can be a charge, or this quantity Q can be a length, some quantity, length, area, or mass, or even something like, say, marks, the physics marks of students in a particular class. Now this quantity Q, for example, let us take it to be a simple quantity like length. This quantity Q, say the length of a stone or length of an object. So when it is measured using a particular device. So in order to get the exact measurement of length, usually what is done is this length of the object, say the length of the an object, stone, or a length of a cylinder, it is measured a number of times, say using a very accurate device like a vernier calipers, a number of times. First time when the length is measured, or when the quantity Q is measured, first time when its value is measured, let the value, first time when it's measured, let the value be taken as Q1. Next time it's measured, so slightly different values it can come. The reason is when an instrument is used for measurement, the instrument, while taking the measurement, small errors can come. So slightly different values. So Q1 and Q2 will be almost equal, but they'll not be exactly equal. Slight difference will be there. So second time it's measured, it's coming as Q2. So third time it's measured, it's coming as Q3. Like that, a number of times it's measured. So in general, so let the value be taken as, say, some in between value between the first and last value be taken as Qk. So last value, so n times let it be measured. So n number of times the quantity Q is measured. So n values are obtained. All these n values, because of various reasons like errors, say in the process of measurement, or error in the instrument itself, or error in the object itself. So when we're measuring a cylinder with a vernier caliper, cylinder can have deformities, slight deformities. So along different lines parallel to its axis, slightly different values can come. So due to various reasons, slightly different values can come. Then what is done is, in order to remove all these errors, what is the usual process? The usual process, average of all these values is taken. Now what is the meaning of this average? That's what is this topic, average, the definition of average. So what is the meaning of this average? Now the meaning average has been defined in such a way that it gives a proper understanding of the quantity. So rough idea of the many values of the same quantities. So it's defined in such a way that it lies actually between the minimum value and maximum value. Let the minimum value be, say, Q1. So all the values are almost same, but let the minimum value be taken as q1 and the maximum value for convenience can be taken as q1. So average of a particular quantity when it's measured a number of times, it's defined in such a way that it always lies between the minimum value and the maximum value, and it gives exactly the rough idea of the value of the quantity in such a way it has been exactly defined. So what is the importance of the why average has been defined? The reason for the definition of average is very simple, because it actually deals with a large number of values of a particular quantity. For example, physics marks of students in a particular class. Number of students in the class can be 60, 70, 80, 90, 100. So average is defined in such a, so average of all these values of the marks of all the students, or the average of all these different values of the quantity q. So it's defined in such a way that it gives the, so we need not see all the values separately. It takes long time to see all the different values, n number of values. It can be 10, 20, 100, 200, sometimes related to say tiny particles, minute particles like molecules, etc. Number of particles, number of these values of a particular quantity, say for example energy of the molecule, number of the molecules can be very large, but the average of all these large quantity, large number of values is helps in knowing roughly the values of all these different large number of values. So that way it has been defined. So we need not see each and every value separately. It will take a long time. Just by seeing the average, we'll getting rough idea. Supposing average is defined in such a way that exactly speaking like this. Average is defined in such a way that if the average value happens to be very high related to this n number of values, the average is very high. It simply means that all these values also will be high. You roughly I'm telling. So if the average of all the values is very small, it roughly means that it simply means that all these values are also very small. That way average has been defined. And one very most important property of the average of n number of values is very important property. It always lies between the minimum and maximum value. This is a most powerful property of average. That way, and use of average is what? Just by looking at the average, we'll be getting the rough idea of the different n values of that particular quantity, or the physics marks related to 60 students. If we know the class average of the physics marks will be just, if the class average is very high, means it means that most of the students are getting high marks. That's the purpose of the definition. Now how it has been defined, average of all these n values is defined. It's defined in a simple way. Already we know the definition. What is the rough definition? Already we know the definition. So average of the quantity q, many times we have used this. It's simply defined as, it's actually, we usually take it as what? Sum of all these values q1 plus q2 plus and so on up to qn. The sum of all the n values divided by the total number of values. This is how. So this we usually roughly use it as the definition, but this is only the definition which is actually obtained from a more accurate definition, more original definition. So how the average has been defined? So now the most important thing is when the quantity is actually measured, due to various reasons all these values can be slightly different. Usually only in certain very rare situations all the values can be exactly equal, but usually that will not be happening. Slight difference can be there, and some one or two values can be even more different also, completely different from the rest of the values. But in all such cases, when n values are considered, average value will be giving an exact or rough, a very clear idea. It may not be exact idea, but a very clear idea about the values of all the n values. So how average value has been defined? So average value of a number of values of a physical quantity or any quantity is defined as some value which lies between the minimum and maximum value. It is defined to be an imaginary value, which actually lies between the minimum value and the maximum value in a group of n number of values, and it's defined to be an imaginary, exactly speaking, constant value. It's defined to be an imaginary constant value. Okay, so already I said the main purpose of the average value is it's defined in such a way that it gives the rough idea of all the n values, because all the n values in most of the situations the number of values will be so huge, like the energy of the molecules of a gas, it will be so huge that each and every value among the n values can't be exactly, not possible to see. So average value is defined in such a way that it gives a rough idea of all the values. So how average value is defined now? That's the important thing. So average value, always important thing is it's defined in such a way that this also will be getting from the exact definition itself. This is a very important property I said. It always lies between the minimum value and the maximum value, which gives the rough idea of all the n values of the particular quantity. So it's defined as an imaginary constant value in all the n cases. So all these n values are usually will never be equal to each other. Always at least some slight difference will be there. In some cases more difference also can be there. Usually they'll not be coming to be exactly equal. But average value is defined in such a way that it is that imaginary constant value in all the n cases. In all the n cases, if all the n cases happen to be exactly constant, it's never possible that imaginary constant value in all the n cases such that the sum total of all these. So what is average value now? The meaning, roughly we are getting the meaning, we are coming close to the definition. So average value is defined to be that imaginary constant value. I'm just writing this imaginary constant value as q constant. Really it's what? It is an imaginary constant value. Imaginary constant value in all the occurring in all the n cases, which will never be happening. All the n cases will never be constant. Constant means same. It is that imaginary constant or same value in all the n cases such that the sum total of all these n values. We know what is the sum total of all these n values. Really, the sum total of all the n values is what? Q1 plus Q2 plus Q3 plus so on up to Qn. Now this sum total of all the n values in this imaginary situation. So average value is defined to be that imaginary constant value in all the n cases. In all the n cases, that imaginary constant value such that the sum total of all these n values, now in this imaginary situation, now in the imaginary thing here is what? All the n values are assumed to be constant. So that particular imaginary constant value in all the n cases such that the sum total of all these n values, now the sum total of all these n values is really what? Q1 plus Q2 plus Q3, in which usually they are different, but now assuming that they are coming to be exactly same, equal to the some constant value, then the sum total of all these n values will be what? Q constant plus Q constant plus Q constant plus Q constant and so on up to Q constant n times. So n times Q constant is what? N into Q constant. So that imaginary constant value in all the occurring in all the n cases such that the sum total of all these n values exactly remains the same as in reality. So now the sum total of all these n constant values is nq constant. This sum total of all the n values should be exactly equal to the sum total of all the n values in reality. In reality, what is the sum total of all the n values? Q1 plus Q2 plus Q3 plus. So the definitions are the most powerful things in science and technology. However tough a definition appears to be, it should not be just taken lightly. Don't think that this is useless like that. So however tough it appears to be, really that's the easiest, gives the easiest meaning, simplest meaning. So definition of anything, any quantity or any operation or any process or any quantity, it's always gives the simplest meaning in the simplest possible words. So though in the beginning it appears to be a little tough, but still it will not be tough. Even the toughest questions also can be become very simple by using the definition. So initially it may be looking a little difficult, but really it will not be difficult, as we can see immediately in the next one or two steps we can see. So what is the average value of a number of values? It is that imaginary constant value in all the n cases such that the sum total of all these n values. Now in the imagined situation, we are just imagining that all these values are constant. If they happen to be constant, that imaginary constant value such that the sum total of all these n values now exactly remains the same. It's exactly equal to what? Always observe the cursor. So whatever equation, whatever step, whatever thing I'm explaining, I'm just pointing out with the cursor. So compulsorily, as you are listening to the explanation, compulsory you have to be observing the cursor. So sum total of all the n values here in this imaginary situation remains really the same as the sum total of all the values in reality. Sum total of all the values in reality is what? Q1 plus Q2 plus Q3. They are different, Q1, Q2, Q3 and so on up to Qn. Usually they are different, most of them are different. So in the imaginary situation, the sum total of all these n values, assuming that each value is a constant, It's an imaginary constant. This will never be happening. Then the sum total of all these n values in this imaginary situation remains exactly same as the sum total of all the n values in reality. Now right hand side, observe here, q1 plus q2 plus q3. This is written as sum, is always usually written as, it's denoted by sigma. It's written as sigma q1. So sigma q1 simply means that it's occurring continuously. q1 plus q2 plus q3. It's difficult to write this big expression, so it's written as sigma q1. Now another way of writing the same thing is it is written as sigma qk, because all the suffixes, the bottom of each quantity, each value q, you see 1, 2, 3. So such a number which is written at the bottom, such a number or an alphabet which is written at the bottom is called as suffix. It's written as a suffix. After the quantity it's written. So prefix means it's written before. So this suffix, whether it's 1, 2, 3 or so on up to n, is then generally taken as k. So sigma qk, as k ranges from 1 to n. That way it's written. That's why it's written. So this particular constant value is simply defined as, so this particular imaginary constant value in all the occurring in all the n cases, such that the sum total of all these n values exactly remains the same as in reality. This particular constant value itself is called as average of the particular quantity q, or it's simply also called, more accurately, it's also called as the average of all these n values. So simply this itself is called as the average of all the n values. Simply written as q average. So n into q average is this much. So n into q average is this much. So from this what we are getting is, therefore, so whatever things we are saying here are simple, nowhere any complication is there. Therefore what we are getting is what? Very simple. Therefore average value of all the n values, or average value of the quantity q when it's measured n number of times, or simply average value of all the n values is simply coming as, take n to other side, it can be written as sigma qk, as k ranges from 1 to n divided by n. So this comes to be the final expression, or very useful form of the expression for average of n number of values. So the average of n number of values, q1 plus q2 plus q3. So q1, q2, q3, n number of values are there, q1, q2, q3, and so on up to qn. So how the average of all that is, this n values is obtained, sum of all the values divided by total number of values, or sum of all the n values divided by the number of values n itself. So from this the second definition of average comes. So this actually gives the first definition. This is called as the definition 1 of average. So what's the definition 2? Definition 2 is very simple. This is the definition which we have been using in almost every subject, every lesson last 3 to 4 years. We never use the definition 1, because definition 1 is a completely abstract, that is something like imaginary or something like theoretical definition. So always the toughest thing in science and technology, science and engineering, is understanding of the theory. So mostly it's abstract, so its applications or problems or equations will be much more simpler to understand. So the definition 2 we have been using as the actual definition of average. So what's the definition 2? Simply average of a number of values, nothing but sum of all the values q1 plus q2 plus q3 and so on up to n values divided by the number of values. So this is the second definition of average. So both the definitions are not difficult, but always important thing now is the second definition actually comes from the first definition. So any complication comes. So definition 2, though we are using it as a because first definition is a little complicated, it's highly imaginary. So always in order to get into the first definition, always a lot of thinking is required, so it will not so easy. So while applying the average, always the equation will be very simple. So usually practically this is taken as the practical definition or simpler definition of the average. But sometimes any complication comes, second definition will never be working, will never be helping, only first definition will be helping. So always that's the original, that's the real definition. This is only the equation obtained from the definition after 2 or 3 steps. Just see here, first step, second step, third step. After the third step we are getting the definition 2. So this is not really a definition, it's only result obtained from the definition, though we are practically using a definition. So that's the thing about the average. So now, so whatever things we are seeing here are very simple, nowhere any complication is there. Now just actually most of the space is actually occupied by writing only. Actually there is no place, but actually some more little space is required. So there's not much space here, so I'll try to take a little space on the right hand side of the next topic. So right hand side. So the definition of average, once again, just see. So whatever things we are seeing here are simple, nowhere any complication is there. So a quantity is measured n number of times. So Q1, Q2, Q3 like that. So Q and so on up to Qk and so on up to Qn. So all these values are usually different. So